Hello everyone. Do you know that more than 80% of the robots use electricity as power source? In today's session, let's understand how electrical engineering plays an important role in robotics.
Let's look at the learning objectives of this video. In this video, we will see electrical components, which are the various electrical components we are going to use. We are also going to talk about principle of operation of DC motor, principle of operation of servo motor, principle of operation of stepper motor, and finally, we will understand which motor we should use based on what is our functionality.
Electrical engineering is the field of engineering that generally deals with the study and application of electricity. Though electronics also deals with application of electricity, it is different than electrical in that it studies application of electricity for information processing. When we talk about electricity, we need to understand about three most important components of electricity. They are current, voltage, and resistance. Current is represented by English letter I and is measured in ampere. Voltage is represented by English letter V and is measured in volts. Resistance is represented by English letter R and is measured in ohms. Ampere, volt and ohm are measuring units for current, voltage and resistance, just as kilogram is measuring unit of weight. A typical electrical circuit is as shown on your screen. The circle represents presence of voltage in the circuit. The positive and negative signs in the circle represent the positive and negative terminals of a battery. The letter small I represents the presence of current. The arrow shows the direction of current flow, while the zigzag line represents the resistance. Before we move further, let's see some electrical components used in robotics. They are motor, used to convert the electrical energy into mechanical energy. Wires, used to flow electricity from one point to another. Without wires, we cannot electrically connect to physically separate parts. Power supply, this is heart of any electrical circuit. In our case, heart of the robot. Switches, these are used to connect or disconnect electrical supply to an electrical component. Controllers, these are circuits which are like advanced switches and control the flow of electricity, which in turn determine the robot action. For example, if the robot goes forward or reverse or if it turns. In the next slides, we will discuss in detail about the motors and their working principle. Motor is an important part of robotics. As we have seen earlier, more than 80% of robots use electricity as source of power. Now we need to convert this electrical power into mechanical power so that we can get the required motions. This is done by the motor. We determine which motor to use based on four important parameters. These parameters are mentioned for each motor and you should pay attention to these parameters when you buy a motor. These parameters are rated voltage, rated current, RPM at rated voltage and stalling torque. Rated voltage and rated current are known as input parameters, while RPM and torque are output parameters. The rated voltage and rated current determine what kind of power supply is needed to operate the motor so that the motor functions properly. The RPM or rotations per minute determines the speed of motor at the rated voltage. The speed may vary if the voltage varies beyond the rated voltage. Torque is a circular or rotatory force. It indicates the capacity of motor to lift or pull load. If motor is used to pull or lift higher load than the stalling torque of the motor, then it may not function as required or may eventually damage its windings or gear system. There are different types of motors which can be used for our purpose. They are DC motor, servo motor, stepper motor. Let's first see the principle behind DC motor, servo motor and stepper motor. We will then come back to understand the difference between each type of motor. This will help us in determining which motor to use for the purpose at hand. A DC motor works on a principle that when a current carrying coil is placed in an electromagnetic field, it experiences a force called Lorentz force. Let's understand why and how does this coil rotate, and how do we get a DC motor from this. Let's take two magnets. The opposite poles face each other as shown on the screen. You can now experience that the magnets are trying to attract each other. This is an electromagnetic field which is formed between the magnets. The direction of the lines of magnetic field is from North Pole to South Pole. Now insert a rectangular coil between these magnets. The coil is placed in a horizontal plane, that is, it is horizontal to the ground. The coil has a commutator segment on the end which is in contact with the brushes. The brushes are connected to a battery which provides current. Direction of this current is inward on the left side of the coil and outward on the right side of the coil. Now as current starts flowing through the coil, a force called Lorentz force acts on the coil. The direction of this force is explained by Fleming's left-hand rule. Extend the index finger, middle finger and the thumb of our left hand in such a way that they are mutually perpendicular to each other. Fleming's left-hand rule now states that if the index finger represents the direction of magnetic field in which the coil is placed, and the middle finger represents the direction of the current through the coil, then the coil experiences a force in the direction represented by the thumb. The direction of this force is mutually perpendicular to both the direction of magnetic field and the current in the conductor. Thus an upward force acts on the left hand side of the coil while a downward force acts on the right hand side of the coil. The combination of these forces makes the coil rotate. The commutator and the brush assembly ensures that the current always flows inwards in the left hand side coil and outwards in the right hand side coil, thus ensuring a continuous rotation. A DC motor usually rotates at high speed and has very less torque. For robotics, we will need DC motors which rotate slow and have higher torque. This is achieved by adding a gear set. Thus, the DC motors we use in robotics are geared DC motors. Rotation of DC motor cannot be precisely controlled. In certain robotics applications, such as robotics arm, we will need precise control over the rotation. In such cases, we make use of servo motors. Servo motor is an advanced DC motor. It is made up of a geared DC motor and two additional components called error amplifier and position sensor. The position sensor is usually a potentiometer which reads the position of the shaft and provides a feedback to the error amplifier. The second input to the error amplifier is the control pulse which determines the direction of rotation as well as the expected rotation angle. The error amplifier keeps on providing output till there is a difference in the actual shaft position and the required shaft position. The error amplifier output is 0 when the required shaft position is same as the current shaft position. Thus we can move the shaft to a precise position. A stepper motor has multiple toothed electromagnets arranged around a central gear-shaped piece of iron. In the stepper motor shown on screen, we have 4 electromagnets and a 25-teeth iron rotor in the center. As the electromagnet 1 is turned on, attracting the nearest teeth of the gear-shaped iron rotor, with the teeth aligned to electromagnet 1, they will be slightly offset from the right electromagnet 2. The top electromagnet 1 is then turned off and the right electromagnet 2 is energized, pulling the teeth into alignment with it. Then the bottom electromagnet 3 is energized. Another one-step rotation occurs. Finally, the left, which is the fourth electromagnet, is energized. This causes rotor to rotate again by one step. When the top electromagnet 1 is again energized, the rotor will have rotated by one tooth position. Since there are 25 teeth, it will take 100 steps to make a full rotation in this example, which means that every step is 360 divided by 100 or 3.6 degrees. Thus a stepper motor rotates precised but predefined steps. The angle covered by each step is determined by the number of magnets used and the number of teeth of the rotor. As we have understood the working principle of all three types of motors, let's now understand how to determine which motor to be used. For that, let's compare some parameters of these motors. Assembly. DC motor has a simple assembly where we hang a current carrying coil inside the magnetic field formed by two opposite poles of magnets. A servo motor uses a DC motor, a gear set, an error amplifier and a position sensor, whereas a stepper motor uses toothed electromagnets around a geared motor. Rotation. A DC motor can rotate continuously in both directions. A servo motor, though can rotate in both directions, it can only rotate plus or minus 90 degrees. A stepper motor again can rotate through 360 degrees. Control. DC motor stops when we remove the supply from motor and hence we cannot precisely control the final position. A servo motor's final position is applied as a control input and hence it is very precise in its final position. A stepper motor has predefined steps and hence we can precisely control the final position. Speed. A DC motor and a servo motor can rotate at higher speeds, while the stepper motor rotates slowly. Analyzing all these parameters, we can conclude that a DC motor can be used where we need fast and continuous rotation and where precision control is not important. For example, in toys, water pumps, etc. A servo motor is used where we need precise position control but within a limited range as we can only rotate 180 degrees back and forth. Some examples of servo motor usage are robotic arm or aeroplane rudders. A stepper motor is used where precise control is required over a long rotation, that is, more than 180 degrees. Example of stepper motor usage is 3D printers.
Come to the end of the video and we have understood the various electrical components which we have used in robotics. We have seen the working principle of DC motor, the principle of operation of servo motor, principle of operation of stepper motor, and finally we compared all these motors and we understood where we should use which motor.